Hi, welcome to Section 7.4 Notes on Similarity in Right Triangles. We're going to go over this first little bit in number 1 and 2, and then I'm going to show you 2 different methods for doing these, and then let you practice both methods, and then you can decide which you like better from there. So first thing is similarity in right triangles. It says the altitude to the hypotenuse of a right triangle divides the triangle into 2 triangles that are similar to the original and similar to each other. Okay, so if you look at this picture down below on number 1, you can see, there's an original triangle ABC that's a right triangle. If you remember back from chapter 5, an altitude comes from a vertex and forms a right angle with the other side. So AD is an altitude. And so that's kind of splitting the original triangle into 2 triangles. And so now, I can see that angle is also going to be a right angle. And so now basically I have 3 right triangles, kind of the biggest one, the original one, and then a medium-sized one, and then a smaller one. And they are all similar to each other. So one method of doing the work for section 7.4 is to think of them as similar triangles instead of proportions like we have been doing. But before you can do that, you have to make sure you have it all figured out in terms of what's congruent to what and what corresponds with what. Because remember, we said if triangles are similar, then the corresponding angles are congruent and the corresponding sides are proportional. So you can kind of see the steps right beside example 1. It says draw the 3 triangles in the same orientation. So it doesn't really matter what orientation, but you can see here, if I go ahead and label this first triangle as triangle ABC, then you can see I can go ahead and put my right angle here, and that's where A is. And you can see that the way this was drawn, it doesn't matter how you draw it, but the way this is drawn, this is kind of the shorter side. So I'm going to put B up here, and you can see down here is C, which is the longer side. And, I want each of my triangles to be oriented the same way. So you can see how they're all facing the same way. Before I start labeling more, the way I can show you what angles correspond with each other is, let me get a different color here. Okay, I can see that the big triangle ABC and the medium-sized triangle ACD, they overlap at this particular angle right here at C. Okay, so I know that angle is congruent for both of those triangles. Okay, I also see that the big triangle ABC and the little triangle ABD, they overlap at this angle right here. So I'm going to give it 2 marks at B. Okay, so now if you look at the big triangle ABC, you can see it has a 90, a 1 mark, and a 2 mark. Okay, if we look at the medium triangle ACD, it has a 90 and a 1 mark. We don't really know what those angles are, but we know that if one's 90 and one's 1 mark, the other angle has to be a 2 mark. Okay, and we know that if triangle ABD has a 90 and a 2 mark, then the other angle has to be a 1 mark. Okay, we're doing this with numbers, that might even make more sense, but we're just trying to get figured out what has to be congruent to what. So now if we go ahead and get our triangles figured out here, I know all these are right angles. And I can see the main big triangle, if I just said the shorter side is AB. So I can see if I look at the main big triangle, block out everything else, I've got a 90, the B has a 2 mark, and the C has a 1 mark. Okay. If I look at, and we'll call that triangle 1, the main big triangle. Okay. Triangle 2 is like the medium-sized triangle that I'm looking at right here. And so it at the 90 is the D. Okay. Its kind of shorter side would have an A right here. And, again, I can see the 90 and the 2 mark. I want these triangles oriented the same way. And then down here at C is where the 1 mark is. Okay. And then for the little triangle, again, I want it oriented the same way. I've got 90, I've got 2 mark, I've got 1 mark. And I know that my right angle for the little triangle, if we want to call it triangle 3, then I can see that the 90 is the D. I can see the 2 mark is the B. And I can see the 1 mark is the A. Okay, let's see if I can move this up just a little bit. Okay, so now we can see the angles that are congruent to each other. We can see the angle C is congruent for the big triangle and the medium-sized triangle. And we see angle B is congruent for the big triangle and the little triangle. Okay, so again, we can see what's corresponding. And then once we have that figured out, we can say the similarity statement, which they already did for you. We'll do it on the next one. But we can see here that, triangle ABC, 90, 2 mark, 1 mark is similar to DAC, 90, 2 mark, 1 mark is similar to DBA, 90, 2 mark, 1 mark. Okay, once we know that, if we knew numbers on some of the sides, we could set up proportions to solve for the missing pieces. And we'll see that down below in a minute. Okay, so let's go ahead and try number 2. They didn't give us the triangles this time, so let's go ahead and draw them ourselves here. So again, we can see there's 3 triangles in this picture. So I'm automatically going to just draw a big one, a medium-sized one, and then a smaller one. Okay, I know they're all going to be right triangles, so I'm going to go ahead and get my right angles in here. Okay, and I know they're all going to end up with a 90, 2 mark, 1 mark. I'll worry about getting the letters on there in just a minute. Okay, so let's go back to the original triangle. Again, my original triangle I'll call triangle 1. My medium-sized triangle I'll call triangle 2. And then my smallest one I'll call 3. Okay, so let's mark some angles on here. We know that the big triangle 1, XYZ, and the medium triangle 2, WZY, we can see that they both have a right angle. They're both right triangles, but then we can see they overlap at Z. And so we're going to give Z a 1 mark. Okay, and then we can see that this angle over here has to be a right angle. That doesn't look very good. Okay, yeah, I'm gonna fix that. I don't like it. Okay, and then we can see that the main big triangle 1, XZY, and the little triangle 3, that they overlap at angle X. And so we're going to give those angles 2 mark. Okay. Now, if we look at the main big triangle 1, XZY, we can see it has a 90, a 1 mark, and a 2 mark. So we know the medium triangle 2, needs a 90, 1 mark, 2 mark. And we can see that angle 3, the little triangle, has a 90 and a 2 mark. So now it needs a 1 mark. Okay. So if we come over here and label our triangles, we can see the main big triangle 1, its 90 is the Y, its 2 mark is the X, and the 1 mark is the Z. For the medium triangle 2, we can see its right angle is W. That's not very good, W. Try that again. Okay. And we can see its 2 mark is the y, and we can see its 1 mark is the z. And for the little medium triangle 3, XWY, we can see that its 90 is the W. Oh, not a good W again. I can do better. All right. And then we can see the 2 mark is the X, and we can see the 1 mark is the Y. So there we go. So now if we do these similar triangles, okay, we can see that if I say X, Y, Z, doesn't really matter how I name the first one, but it'll matter how I name the second ones. X, Y, Z is 2 mark, 90, 1 mark. So I need to follow the same one for the next triangle. 2 mark, 90, 1 mark, Y, W, Z. And for the third triangle, the little one, again, 2 mark, 90, 1 mark. So X, W, Y. Okay. So that's kind of the right idea of how we're getting set up, and then we can do the work from there. So on examples 3 and 4, it says redraw the similar triangles and then solve for X and Y. So we can do the same thing we just did to start it off, but then we can use that information to solve for some missing pieces here. So I'm going to go ahead and draw my 3 triangles. There's my big triangle. There's my medium. There's my small. I know they're all right triangles. I can call them triangle 1, 2, 3 if that's easier to talk about them. And I know they're all going to have a 90, a 1 mark, and a 2 mark. I guess it doesn't matter where you put the 2 mark and 1 mark. The way I have it in the notes that I posted online is I put the 2 mark up here. So it doesn't really matter. You just want to stay consistent. Okay. So again, if we go back to the original up here, I need to get my markings on here. So there's my right angle. That doesn't look very good again. And I know that the big triangle 1 and the medium triangle 2, they overlap at angle A. So I'm going to give angle A a 1 mark. And I can see that I can see the main big triangle and triangle 3 overlap at angle B. So I'm going to give it a 2 mark. And I can also see then that the big triangle has a 90, a 1 mark, and a 2 mark. So the medium triangle has a 90, a 1 mark, and then needs a 2 mark right here. And then the little triangle, triangle 3, has a 90 and a 2 mark, so it needs a 1 mark right here. So we go and label the triangles. The main big triangle has the right angle at C. Its 2 mark is B, and the 1 mark is A. Okay, and if we are still looking at that main big triangle, actually, let me go and get the letters for the other ones first. Now we look at the medium-sized triangle. We can see the 90 is D. We can see the 2 mark is C, and the 1 mark is A. And then for the little triangle, we can see the 90 is the D, and the 2 mark is the B. It's going to look similar. Let's make those look a little better. That's better. Okay, and then the 1 mark of the little triangle is C. Okay, now let's go back. I'm going to switch colors to purple, and I'm going to label the links of the sides of the things that I do know. So if I look at the main big triangle, I can see BC has a length of X, and I can see that AB has a length of 21 plus 4, which is 25. Okay, so that is AB. Okay, if I look at the medium-sized triangle, I see AD is 21, and I see that DC is Y. If I look at the little triangle, I see DB is 4, and I see that BC is X, and I see that DC is Y. That one has a lot of information. All right, so now I don't know all the links, but I know enough to set up some proportions to solve for the missing pieces. Um, so if I look here at triangle 1 and triangle 3, I see that I can set up a proportion to figure out what x is. If I go x from the big triangle, which is BC, over 4 of the little triangle, which is BD, because they correspond with each other. They're both between the 90 and the 2 mark. Then if I come back to the big triangle, triangle 1, there's a 25, and it's between the 1 and the 2 mark. And so on the little triangle, it corresponds with the x, which is between the 1 and the 2 mark. Okay, so once I set that up, now I can cross multiply. X times x gives me x squared. 25 times 4 gives me 100. I can take the square root of both sides. And once I solve, I end up with x equals 10. So that gives me one of the links by solving a proportion. Okay, now if I want to figure out what y is, I can see that I can set up a proportion with triangle 2 and triangle 3. Okay, so to do that, I can do y, which is CD of the medium-sized triangle, over BD, which is 4 for the little triangle, is equal to 21 DA for the medium triangle, 2, over Y DC for the smallest triangle, triangle 3. Okay, again, you're just finding things like in this case, if it helps you to circle this goes with this and this goes with this, that's fine. But again, you're just looking at things that correspond with each other, looking at the angle markings to see what matches up with what. You're not always going to get an X and an X and a Y and a Y. Sometimes there might just be one X in the equation or one Y. So just keep that in mind. But in this particular case, we end up with Y squared is equal to 84. When I take the square root of both sides, if you try to type square root of 84 in the calculator, you don't get a whole number, you get a decimal. So I do want you to practice simplifying the radical, put in the radical in simplest radical form like we practiced the other day in class. And so to do that, if you think of what perfect square goes evenly 84, it is 4. So I know that 4 times 21 gives me a square root of 84. And so now I can take the square root of 4 and get 2. I can't take the square root of 21, so I'm going to leave that as the 21. And that is my answer in simplest radical form. Remember, like we said before, if you want to double check to see that you did that right, if you type square root of 84 in your calculator, you'll get 9.2. If you type 2 square root of 21 in your calculator, you'll get 9.2. And so that's a good way to verify that you got that simplified down correctly. Okay. But you do want to be in the habit of leaving it in simplest radical form. Okay, I'm going to have you try number 4. It's going to be very similar, and then you can check it on Canvas because I have the solutions for that, so you can kind of check to see that you did it right. And, keep in mind the one thing that's you may need to do before you get started is figure out what this missing piece is right here. But I think you can do that. If you look at what else is in the picture, I think you can find that missing piece. And then the problem is going to be very similar to what we just did. Okay, so this was method 1 using similar triangles. I'm going to label it as method 1. Okay, and then now I'm going to show you method 2. And then you can just decide what you like better from here. So in this case, you can see the steps are kind of written here. A little formula that says the altitude, which is that line that goes through the middle and forms a right angle with the other side, over part of the hypotenuse is equal to the other part of the hypotenuse over the altitude. So it's like a little formula you'd have to remember. And you can solve for the missing piece there. And then you would use Pythagorean theorem, a squared plus b squared is equal to c squared, which works for any right triangle when you know two sides and want to find the third, to find the other missing sides. So let's do that down here for example 1. Then I'll have you try example 2 this method, and then you can decide which way you like better. So on this one, if we think of the formula again, now you should still be able to see your formula. I need some room to work, but I think you can see that is, it said the altitude, which is y, over one part of the hypotenuse, which is 5, is equal to the other part of the hypotenuse, which is 5, over the altitude again, which is y. Okay, so once we cross multiply, we end up with y squared is equal to 25. And once I take the square root of each side, then I get y is 5. So the kind of nice thing about this one is you don't have to do all that angle stuff at the beginning, but it is an extra formula to remember. So you just have to decide which you like there. Over here on the next part, we now know that y is 5. So that's kind of interesting. We're getting lots of 5s in this one. It's not always going to be the same numbers. But now if we want to figure out so I went ahead and put that 5 in the picture. Now we can use Pythagorean theorem. It may have been a little while since you've done Pythagorean theorem, but it's a handy formula. We'll do more with it in the next chapter. But it's a good review now. I know you've done that in the past. So a right triangle, you can use Pythagorean theorem anytime you know two sides and want to find the third. Remember, when we have a squared plus b squared is equal to c squared, a and b are the legs, the two sides that make up the right angle, and c is the hypotenuse that's across the right angle. So in this particular problem, if I look at the picture, I can see the legs are my 5s because they make up the right angle, because we're looking at this triangle right here right now. So we're saying 5 squared plus 5 squared is equal to the hypotenuse, which is the x, because it's across the right angle. So if I solve for that, I get 25 plus 25 is equal to x squared. Add those up and I get 50. When I take the square root of both sides, then I end up with x is equal to, square root of 50 is 25 times 2, because I was looking for that perfect square that goes evenly into 50, and 25 is a perfect square. 25 times 2 means the same thing as 50, so that's why I'm allowed to write it. And now if I take the square root of 25, I get 5. I can't take the square root of 2, so I leave the 2 in. And so I end up with 5 square root of 2 for my x. And my y is equal to 5 for the y. All right, so again, this is method 2. I want you to try number 2 here using method 2. And then, like I said, you can figure out which one you like better. And once you do number 2 here, you can check on Canvas to make sure you did that one correctly. And let me know if you have any questions.